Astronomers were excited to discover the interstellar object last year. It was named Oumuamua.
Oumuamua, which is an object that we detected in space that you believe could possibly have been extraterrestrial.
Everyone thought Oumuamua was gone, but it's back, and it doesn't look like it's going to stop. It caused a lot of trouble when it first showed up in 2017, especially since its orbit was a little off. Scientists thought it came from a different star at the time. Some people think it might be coming straight for Earth this time. Some people even say it's some kind of alien spaceship. But is it possible? Let us find out. A few years ago, the vast field of astronomy was very different from what it is today. Besides that, some things that happen in space are too complicated for us to understand. Imagine a space rock about the size of a football field that is speeding through space and acting in a way that has never been seen before. Even with all of that, we can tell this isn't just a normal piece of space junk floating around. The scientists are trying to figure it out, but they're having a hard time. On the other hand, people watching are feeling a mix of fear and excitement. Scientists know that this item is moving at a speed that doesn't make sense and is going in the wrong direction. Also, did we say that it just popped out of nowhere? It looks like the item has its own thoughts just by looking at it. And just when you think you understand how it works, it speeds up and changes direction, making you keep trying to figure it out. There's no way to make sense of how it acts. But why is this strange object in space acting this way? A comet named Oumuamua was found in 2017. Its name immediately caught the attention of both science and the public when it was found. This was the first guest from outside our solar system that didn't have the bright coma and dust tail that most comets have. Another strange thing about it was that it looked like a cigar from one angle and a pancake from the other. Also, it was too small to be anything but a rock. Things that have been thrown into outer space could have come from a number of different places. Some come from other planetary systems and are drawn to this one by the gravity of gas giant planets that are always destroying their neighborhood, and big crashes can send them hurtling toward each other, which would destroy protoplanets. As the first visitor from another star system, Oumuamua is the first to shed light on how other solar systems work and whether or not they have planets. Because it is the oldest known object in our solar system that is not a star, its name comes from Hawaiian. This means that Oumuamua means a messenger from far away arriving first in Hawaiian. That name worked out pretty well. It doesn't seem to be stopping for anything, even though it is the first object in our solar system to pass between stars. Scientists say it's likely to have a direct effect in 2 weeks. Is this really what they thought? Check back to find out. It was found by a telescope in Hawaii called Pan-STARRS 1 when Oumuamua first came into our solar system. That's why a Hawaiian name was given to it. Besides the fact that Oumuamua was something new in our solar system, there was something else that made it stand out: its shape. The thing looked about 10 times longer than it was wide at first glance. From a certain point of view, it looked like a cylinder. When the readings were first made, the comet was 6.1 miles across. While astronomers have been watching Oumuamua move through our solar system for years, they have finally been able to change these readings. What they said about the size makes it look like it's some kind of pancake shape. As many of these things as there are, have scientists ever found another one in our solar system? It's not made of the same stuff as Oumuamua, but it has the same shape. This was found in the Kuiper Belt, which is past Neptune. The object that looked like Oumuamua was actually a small planet named Arakoth. After NASA's New Horizon probe flew by it on January 1, 2019, this small planet was found. The light curve of Oumuamua was mostly used to figure out its form and size. As the item moved through space, this graph shows how its brightness changed over time. When scientists looked at Oumuamua from its wider side, it seemed brighter. The length of Oumuamua is 377 feet, the width is 364 feet, and the thickness is 62 feet. Thus, it was also pretty small. Its albedo of 0.1 was used to figure out how thick it was. This just means that it reflected about 10% of the light that hit it, which isn't that strange for comet main bodies, but Oumuamua keeps getting more and more interesting. Astronomers naturally became more interested in it after it was found. They just wanted to find out as much as they could about it. One way to do this was to keep pointing more and more binoculars at it. One of the most interesting things they learned about Oumuamua after studying it for a few years was that it had already gone around the sun once. They found out that it was actually leaving the solar system. Astronomers also learned that Oumuamua was very long and ended in a point. The reason they came to this conclusion was because they saw that the lighting changed unevenly every 12 hours. There was one thing, though, that made it clear to everyone that this was a comet and not a rock. You see, comets are known to move faster than asteroids, even though the difference is small. The most important time for this is when they are going away from the sun. Comets start to send out dust and other gaseous comas made of water and other things as they move toward the sun. All of this comes from their outside. It is most often possible to see one tail that looks like dust. The comet left this one behind. Other than that, there is a second tail that points away from the sun and is pushed by gravity. Most of the time, this second tail is made up of air and particles that have been pushed away by the sun's light. Besides these things, the comet may also release carbon monoxide and organic molecules that are stuck inside it. Oumuamua is a very interesting comet that doesn't follow the rules we know, but even with all of this, it's still pretty hard to stop. Does that still mean it will have an effect in 2 weeks? Check back to find out. While Oumuamua was traveling around the solar system, it was bent by the sun's gravity. It was caused by several things, and the first reason is that it is very small. In this way, the little push that was made when the hydrogen gas spewed out of the ice could be felt. Because of this one thing, this comet has set apart from all the other comets in our solar system, especially the ones that have been studied a lot. Each comet comes from a different place in space. And when you think about how most comets come close to the sun on regular intervals, a comet's bright coma is made when it throws off water and other molecules as it goes around the sun. This is mostly caused by the sun's heat. Besides that, comets usually have tails of gas and dust as well. Comets and asteroids are not the same thing, as we've already seen. They are also lighter, which makes it easy for them to stray from their elliptical paths when the gases released give them even a little push. This is something that we know a lot about things in our solar system, like planets and asteroids. Oumuamua was a comet that astronomers had never seen before. It wasn't made up of the same things as other comets in our solar system, and it was moving in a strange way. Astronomers did everything they could to learn as much as they could about the comet, even though it was hard to understand. One thing they thought a lot about was what the comet was made of and what was pushing it outward. The main reason for this was that the comet was found without a coma or tail. It was also too far away from the sun and too small to collect enough energy to let a lot of water out. There are a lot of ideas about what this is. Some people think it's an iceberg of hydrogen gas releasing hydrogen gas. This iceberg can be thought of as a big fluffy snowflake that has been pushed by the sun's light pressure. Some people say it's a light sail that was made by people from another planet. Some say it's a spaceship moving on its own, though. Comets are an important part of our solar system. They are mostly ice rocks that were around when the solar system was first formed, about 4.5 billion years ago. Scientists can learn some things about what was going on at that time thanks to these comets. These comets have also helped us learn more about some stars and planets. The behavior of comets in the space between stars can help us figure out which stars are surrounded by disks and might one day have planets. Like we said before, comets help us learn about how the solar system formed. They mostly show how the solar system was put together, especially when it was in the protoplanetary disk stage of its development. Scientists can learn more about the early stages of the solar system by studying them, especially when our solar system was pretty small and not very massive. We've been talking about comets and how important they are to the sun. But how did they get there? Comets are actually thrown out by planets that are very far away. This is mostly due to interactions between objects in the system caused by gravity. In the past, the same thing happened to our solar systems. Comets that aren't supposed to be here sometimes find their way towards our sun. We can learn a lot about how planets form in other solar systems from these rogue comets, especially when they come back to ours every so often. Researchers have been keeping an eye on Oumuamua for a long time because they want to learn everything they can about it. After this, they learned a lot, except for one thing. Scientists still haven't been able to figure out exactly where Oumuamua's stellar system is. It will stay this way for a while longer, because this is one of the biggest mysteries about the comet. Still, researchers were able to follow Oumuamua as it went back to its original path. In the end, they learned things that would interest everyone who was keeping an eye on the comet. It's possible that this new information will change how we see the comet. It was found that the comet had been close to 4 stars about 1 million years ago. Only the red dwarf HIP 3757 was close to it out of these 4 stars that it had passed through. One of 2 things is true. Either this is where Oumuamua came from, or the comet has been moving through space for a lot longer. All planetary bodies in a solar system, like asteroids and comets, move very close to the sun. However, if this is true, then Oumuamua's path is not going as planned. Based on a simulation from NASA, Oumuamua's path was just a hyperbolic curve. In other words, it moved so quickly as it got closer to the sun. And because it was moving so fast, the sun's gravity could only slightly change its path. It couldn't get stuck in a loop. What does this mean, though? Does that mean it will go around the sun more slowly? No, that's not the answer. This only means that Oumuamua could keep going until it reached the doorway out of the solar system. In addition, it will do this at a speed of about 16.36 miles per second, faster than the sun. It wasn't until Oumuamua had already made some big moves into our solar system that astronomers found it. They watched it as it moved through our solar system. On September 9, 2017, it reached perihelion, which means it was closest to the sun. It got as close to our star as 23 million miles during this time, which in space means it was closer than ever. Astronomers and scientists kept watching the comet to see what it would do now that it wasn't going through the normal path. Robert Warwick, an astronomer at the University of Hawaii, found something pretty cool during this study on October 19, 2017. According to what he said, Oumuamua had been seen a few times by the asteroid-hunting Panoramic Survey Telescope and Quick Response System. Oumuamua was about 21 million miles from Earth when it was seen by the telescope, and its path showed that it would be as little as 15 million miles from Earth, which is pretty close. The visitor from another world has been slowly leaving our solar system since this finding was made. NASA has written a lot about this comet, including how fast it is moving. They used their records to show that the sun's gravity helped Oumuamua reach a speed of about 54.2 miles per second. However, Oumuamua was very small and moved very quickly, so it could only be seen for a very short time. At that time, the Hubble Space Telescope was the only one that could keep an eye on it for the longest time. 2 of the biggest optical telescopes in the world, the Very Large Telescope in Chile and the Gemini South Telescope, were used to gather data. Once they were joined, the data that came from these 3 sites was enough to make the best pictures of Oumuamua. In fact, information gathered from this point could usually show any star, even one that was as small as a speck. Oumuamua is very close to Earth, and the sun has already swayed it off path. What about Oumuamua? Where is she now? Does it still want to hit Earth, or can't it be stopped? Let's keep going over the facts to figure things out. At this point, Oumuamua has already left Neptune's orbit and is on its way to Pegasus. The comet is now moving through the Kuiper Belt, which is usually a ring of frozen objects that can't be seen by ground-based observatories. The Kuiper Belt is also close to the edge of the solar system. It is clear that Oumuamua has no plans to ever come back to Earth based on its present path and acceleration. Our best guesses are that Oumuamua was something else. At this point, we know for sure that it was something that was thrown out of Oumuamua's orbit by the forces of wandering gas giants. This is clear from the fact that it came from a star system outside of our solar system. Astronomers thought that space objects were a lot like comets before Oumuamua was found. In the end, this was the case for 2I/Borisson. A lot of ideas and thoughts have been put forward about Oumuamua since it was first encountered. Astronomers thought that Oumuamua was just a dead comet whose volatiles, or gases with low boiling points like water, had run out over billions of years. It's likely that this happened while it was still in its own system or when it got close to other stars. Why did it never really have a cometary tail? This is not typical for a comet. Even so, the Hubble Space Telescope proved that Oumuamua's path away from the Sun only showed that the comet moved because of accelerations that were not caused by gravity. This is something that stars often do. When they are going through space, they mostly speed up and move faster by letting out dust and water vapor in a tail. Oumuamua, on the other hand, did not give off any of the volatile chemicals or water that comets usually do. And now experts have even more questions because of this. It seems like this comet didn't really do some of the things that comets usually do. They were sure, though, that it was a comet. Scientists and researchers began to come up with different ideas about what Oumuamua was and how it worked in order to try to explain it. At last, there were two key ideas that stood out, and they were sure that one of them was right. In the first one, Oumuamua is used as a piece of nitrogen ice. Alan Jackson and Steve Desch from Arizona State University came up with this idea. They thought that places like Sputnik Planitia were mostly made up of frozen nitrogen lakes. This was seen for the first time by New Horizons in 2015 as it flew by Pluto. Jackson and Desch said that Oumuamua might be a piece of nitrogen ice that was blasted off of a body like Pluto by a huge impact. This is not a strange event. If Oumuamua needed an extra push, it could have come from the nitrogen that was escaping and being turned into gas by the sun's rays. The reflectivity of comets is known to be about 0.64, which means they reflect light better even if this were true. This can only mean that Oumuamua is smaller than first thought because it looks so pale. After some math, Jackson and Desch found that Oumuamua would have been about 148 feet long, 144 feet wide, and 25 feet high. But this was only true if it was made of nitrogen ice. Maybe the cosmic rays caused the ice on the top to melt. And because Oumuamua is mostly from space between stars, it would free hydrogen from some water molecules. This would make a source of hydrogen gas trapped in Morphos water ice. Daryl Seligman from Cornell University and Jennifer Bergner from Berkeley University came up with the second idea about what Oumuamua was. These two people said that the object Oumuamua was warmed as it passed through the sun. That being said, it wasn't warm enough for the water ice to melt. When they talked about the push, they said it was because hydrogen was fleeing at a rate of 0.4 to 28 ounces per second. This was possible because the warmth might have changed the way the ice crystals are structured. So this idea goes, there is also a very good reason why there was no dust trail. Based on what they said, the dust would stay in the water ice, so Oumuamua would not leave a dust trail. Several other ideas have been put forward about what Oumuamua is like. The one from scientists Avi Loeb and Shmuel Bialy of Harvard University stood out as well. These two said that Oumuamua was a spaceship that was powered by the sun and moved faster than gravity would allow. However, this idea was quickly thrown out by most astronomers. There is some kind of power law division that most things in the universe follow. We can say this because there are not many big people in the group and a lot of small people. Taking all of this into account, could Oumuamua be somewhere in the middle of this range? It is hard to say for sure because there could be a lot of interstellar objects passing through our solar system at any given time. People have even guessed that between 1,000 and 10,000 cosmic objects are moving through the solar system at any given time. But because there are so many of them, we would never be able to see them because they are so far away in the solar system. If you think about it, these objects probably look like they are coming from the way that our solar system is moving through space. It's like how all the raindrops seem to be heading straight for your window when you're driving in the rain. Oumuamua and Borisov are galactic gypsies who spend most of their time just wandering through space between the stars. In the normal solar system, asteroids and comets circle the sun. This is nothing like that. Scientists knew that the chances of these aliens visiting our solar system were very low, so they were not surprised by how rare it was to actually see one. And with these two discoveries about visitors from other planets, experts now think that they happen a lot more often. A planetary scientist at UCLA named David Jewett says that there are 10,000 cosmic objects the size of Oumuamua that are currently only in the orbit of Neptune. Scientists are working non-stop right now to deduce as much as they can from Oumuamua before it leaves our solar system for good. And one thing is certain, The science community will be very upset when it leaves. Scientists have found Oumuamua to be very interesting, and they still do. Its departure will likely mark the end of an age. Even so, it's important to remember that there is still a lot of hope. This is because the Vera C. Rubin Observatory, which will open in 2024, will be able to watch over any object in space. This might be just what scientists and researchers need to keep an eye on Oumuamua. The telescope will have the world's biggest digital camera, with 3.2 billion pixels. Every few nights, the camera will take pictures of the whole southern sky. And scientists will be able to learn a lot from an interstellar object if it is found, just like they did with Oumuamua. This will be possible because the telescope should be able to see things that are 100 times fainter than things that the human eye can see. But the Rubin Observatory will not be the only place where people look for things between stars. NASA will also be looking for things between the stars. Their Near-Earth Object Surveillance Mission, or NEOS-M, is set to launch sometime in 2026. NEOS-M's main job will be to find, track, and describe any nearby objects that are close enough to Earth that they could be dangerous. But even with all of this, Oumuamua might still come back for another stay. Alan Jackson of Arizona State University says that because our solar system has a gravity lens that can bend light, an object like Oumuamua might happen to come back for a second visit. It's not likely that this will happen anytime soon, though, even if it happens. For Oumuamua, it's safe to say that it is already a long way from our sun. Today, scientists and researchers are excited to see what else the universe has in store for them. The Rubin Observatory and NEOS-M are now up and running,